Born Julius Robert Oppenheimer on April 22, 1904 in New York City, J. Robert Oppenheimer entered a world brimming with intellectual curiosity and artistic expression. His family, non-observant Jewish, fostered an environment that encouraged his diverse interests from English and French literature to mineralogy. His younger brother Frank would also pursue physics. Oppenheimer was a precocious student, skipping grades and demonstrating a remarkable aptitude for learning. He even took private music lessons from the famous French flutist Georges Barrère. A bout of colitis delayed his entry into Harvard, leading to a period of recovery in New Mexico, where he developed a lifelong love for horseback riding and the southwestern United States, a passion he later called his two great loves alongside physics. At Harvard, Oppenheimer majored in chemistry but pursued a broad curriculum that included history, literature, and philosophy. He graduated summa cum laude in just 3 years. His academic journey led him to Europe, a vibrant hub for theoretical physics. Despite initial struggles with experimental work at Cambridge, where he famously developed an antagonistic relationship with his tutor Patrick Blackett, Oppenheimer found his true calling in theoretical physics. In 1926, he moved to the University of Göttingen, studying under Max Born, a leading figure in theoretical physics. Here, he connected with future scientific giants like Werner Heisenberg, Wolfgang Pauli, and Paul Dirac. Oppenheimer earned his Doctor of Philosophy degree in March 1927 at the age of 23. His most cited work, the Born-Oppenheimer approximation, emerged from this period, simplifying calculations for molecular wave functions. Upon returning to the US, Oppenheimer accepted an associate professorship at the University of California, Berkeley. He became a full professor in 1936, earning $3,300 annually. Oppenheimer became a charismatic and influential figure, attracting a generation of physicists who admired his intellectual prowess. Students adopted his mannerisms and were drawn to his rigorous approach to problem solving. Hans Bethe noted Oppenheimer's exquisite taste in identifying important problems in physics. He collaborated closely with experimental physicists like Ernest Lawrence at Berkeley's radiation laboratory, helping to interpret the data from their cyclotrons. Oppenheimer's scientific work spanned theoretical astronomy, nuclear physics, spectroscopy, and quantum field theory. He predicted the existence of the positron as early as 1930. His work on cosmic ray showers and field electron emission contributed to the concept of quantum tunneling. With Melba Phillips, he developed the Oppenheimer-Phillips process to explain artificial radioactivity under deuteron bombardment, a theory still in use today. In the late 1930s, his interest turned to astrophysics. Collaborating with students, he explored the properties of white dwarfs, and his work with George Volkoff led to the concept of the Tolman-Oppenheimer-Volkoff limit, which describes the maximum mass of neutron stars before gravitational collapse. In 1939, with Hartland Snyder, he predicted the existence of what would later be known as black holes. These papers remain among his most cited works. Beyond science, Oppenheimer possessed a deep interest in mysticism and philosophy. He learned Sanskrit and read classical Hindu texts, including the Bhagavad Gita, which he called the most beautiful philosophical song existing in any known tongue. During the 1920s, Oppenheimer had largely remained disengaged from world affairs, admitting he didn't even read newspapers. However, by 1934, he became increasingly concerned with politics and international affairs, even donating a portion of his salary to support German physicists fleeing Nazi Germany. In 1942, with the United States embroiled in World War II, Oppenheimer was recruited to work on the top-secret Manhattan Project, tasked with developing the first nuclear weapons. In 1943, he was appointed director of the Los Alamos Laboratory in New Mexico. His leadership and scientific expertise were crucial to the project's success. Los Alamos became a hive of intense scientific activity under Oppenheimer's direction. Scientists from various disciplines converged, driven by the urgent need to create the atomic bomb before Nazi Germany. On July 16, 1945, Oppenheimer was present at the first test of the atomic bomb, codenamed Trinity. The successful detonation unleashed an unprecedented force, forever changing the course of history. A month later, in August 1945, the atomic bombs developed under his leadership were used on Japan in the bombings of Hiroshima and Nagasaki, the only uses of nuclear weapons in conflict to date. The profound implications of this power would weigh heavily on Oppenheimer for the rest of his life. He famously recalled a line from the Bhagavad Gita, "Now I am become death, the destroyer of worlds." The aftermath of Oppenheimer's work on the Manhattan Project left a lasting legacy that would forever change the world. His contributions to science and his role in the development of atomic energy marked a turning point in history. The ethical and moral questions raised by his work continue to be debated to this day, reflecting the complex nature of scientific progress and its impact on society. After the war, Oppenheimer became a national spokesman for science, gracing the covers of Life and Time magazines. In 1947, he was appointed director of the Institute for Advanced Study in Princeton, New Jersey, and became chairman of the General Advisory Committee of the new United States Atomic Energy Commission. He advocated for international control of nuclear power to prevent an arms race and opposed the development of the hydrogen bomb, partly on ethical grounds. However, his past associations with the Communist Party USA and his stances during the Second Red Scare led to an AEC security hearing in 1954 and the revocation of his security clearance. Oppenheimer denied being a party member but identified as a fellow traveler, someone who agreed with many communist goals but not blind obedience to the party. The FBI had opened a file on him as early as 1941. Despite the public humiliation, Oppenheimer continued to lecture, write, and work in physics. In 1963, he received the prestigious Enrico Fermi Award for his contributions to theoretical physics. On December 16, 2022, the United States Secretary of Energy Jennifer Granholm officially vacated the 1954 decision, acknowledging it as a flawed process and affirming Oppenheimer's loyalty. Oppenheimer's legacy is complex and multifaceted. He is remembered as a brilliant scientist who profoundly influenced American theoretical physics, raising it to world leadership. While he never won a Nobel Prize, his work on black holes and neutron stars is now recognized as groundbreaking. As a military and public policy advisor, he was a key figure in the emergence of big science and the integration of scientific research with military endeavors. His life remains a poignant exploration of scientific advancement, moral responsibility, and the profound impact of human intellect on the course of history. J. Robert Oppenheimer's story serves as a powerful reminder of the immense power of scientific discovery and the enduring ethical dilemmas that accompany it. His life, a tapestry of brilliance, controversy, and introspection, continues to resonate in our understanding of science, power, and humanity's future.